Hi, my name is Kevin Williams, Product Manager for JDSU's Test and Measurement. Today I will go over testing AC voltage with the HST 3000. Thank you for joining. If you have a copper testing service interface module attached to the HST 3000, the first screen you'll see when you turn on the unit will be the copper measurement screen. The AC and DC volts measurement is under DVOM, or Digital Volt Ohmmeter. Now there are two ways to reach DVOM. First, you can scroll with the arrow keys, highlight DVOM, and press the OK key, or just press the number 1 on the keypad dialer. After accessing DVOM, the screen presents a snapshot digital display to test AC and DC voltage. The intent here is safety first. Always check for the presence of both hazardous AC and DC, even if you're not expecting to find it. You'll find on the screen 6 separate measurements, auto-ranging and auto-scaling for AC and DC voltage. However, this is just a snapshot view, meaning it is a picture in time. For instance, if I were to connect 52 volts of telco battery across tip and ring and measure with the HST in the snapshot view, the HST would still show 0 volts until I did another snapshot. We find that most field technicians are not comfortable with a snapshot view and prefer to see continuous measurements. I will show you that next. Looking at the bottom right-hand corner of the screen, you'll see a tab with the word continuous that lines up with the F4, or soft key number 4, just underneath. If you select soft key number 4, it will take the first measurement and display it continuously. Starting at the top left-hand side of the screen, the test that you're running is labeled with the lead combination that you're testing, in this case, AC voltage, tip to ring. In the middle of the screen, you'll see 3 possible lead combinations: tip to ring to ground, and tip to ground. The active lead combination is shown in boldface, in this case, tip to ring. Inactive leads, or leads not being used or under test, are grayed out. On the right-hand side of the screen, you'll even see the color of the test leads that are active and under test: black, red, and green for tip, ring, and ground, respectively. Underneath that, on the black background, you'll find the actual measured voltage in large font. Next, close to the bottom of the screen, you'll see the words lowest and highest. The HST monitors the lowest value it measures and the highest value it measures continuously over time, ensuring you don't miss a measurement. For example, if I were using an analog voltmeter and monitoring something over time, I would have to stare at the meter. If I were to take my eyes off the meter for a moment and a lower high voltage condition occurred, I would have just missed the occurrence. Lowest and highest ensure that I never miss a measurement, even if I need to step away from my HST 3000. Near the top of the screen, in light blue shown here, there are 2 phrases: left and right changes the cable pair, and up and down changes test. We'll start with the first one: left and right changes cable pair. That means if you press the left or right arrow, the cable pair you are testing changes. So let's try that. If I press the right arrow, the lead combination moves from tip to ring to ground. Pressing the right arrow once again moves to tip to ground. Pressing right arrow once again cycles back up to tip and ring. Finally, I'll provide 2 practical examples for testing AC voltage. First is a very basic balance test. If you're measuring a dead cable pair, and you see tip to ground measurement of 5 volts AC and a ring to ground measurement of 15 volts AC, then you would know instantly that this pair was faulted. You would know this because the power influence induced on the cable pair is induced equally, tip to ground and ring to ground. There is no discrimination between the 2 conductors. So anytime you see a variance in reading tip to ground versus ring to ground, you know there is something on one conductor that is not on the other. Here's one more practical example for testing AC volts. Let's say you've been dispatched to the customer location because the customer has complained of a partial ring, or a ring short. You test the pair and there is no resistive fault across tip and ring, which would make the line ring short. What you could do is to connect the AC voltmeter across tip and ring the customer's phone. The ring battery on the phone should be somewhere around 85 volts AC, which you would see on your HST. Or you may see somewhere around 105 volts of ring battery from the newer digital switches. If you don't see that, there may be a problem at the switch. That's all for this session. I hope this information was useful. Next, I'll cover testing DC voltage with the HST 3000. Thank you for your time.